Then part D, the currency market price per ordinary share of Kanga Limited is 58 shillings. A call option exists on the company's shares with an exercise price of 52 shillings and with the 6 months to maturity. The option can only be exercised on maturity, that is, it is a European option. The risk-free rate of return is 6% and the variance of the rate of return on the shares is 15%. Required, using the Black-Scholes option pricing model, estimate the value of the call option 6 marks, and down there the formula for Black-Scholes option pricing is provided. The formula is given for the value of a call, that is D. The value of a call, the formula is given, is equal to the standard deviation N D1 minus strike price E negative RT T and D2. This is D2. That is the value of the formula for value of a call using the Black-Scholes formula. So first of all, we are going to calculate D1, and we know the formula for D1 is equal to the natural log of ST over exercise price plus the risk-free rate plus the variance. This variance, you divide it by 2, then we multiply this by T. Multiply by T, divide by the standard deviation times the square root of time. So, candidates, ST is the underlying asset price, X is the exercise price or the strike price, RF is the risk-free rate, this is a variance, T is the time, this is standard deviation, and that is square root of time. So let's substitute the values. We're going to have the natural log of 58 over 52, the asset price and exercise price, plus the risk-free rate is, from the question, risk-free rate is 6%. Yes, 6%. Converted into decimal, 0.06. Then we add, the variance is 15%, converted into decimal, 0.15. This is the variance. We divide the variance by 2. Divide this variance by 2. This variance we divide by 2. The bracket is here. Then multiply by time. The time here is 6 months. 6 months over 12 is equal to 1.5, which is equal to 0.5. So the time is 0.5. So we're going to divide that by the standard deviation. And we know standard deviation is equal to the square root of the variance. Square root of the variance, our variance here is 0.15. Then the square root of time times square root of time, 0.5 times 0.5. So this will be equal to, we go to the calculator. The natural log is in the calculator. So you punch natural log, open a bracket, 58 divided by 52. Close the bracket. This is equal to 0.1092 plus, we remove this bracket, that is 0.15 divided by 2 plus 0.06 times 0.5. This is 0.0675 divide the square root of 15 times the square root of 0.5, 0.3873 plus square root of 0.5, square root 0.5, 0.7071. This should be equal to, so let's add 0.1092 plus 0.0675 divide, open bracket, 0.3873 times, this should be times, multiplication sign, times 0.7071, getting here 0.65. That is D1. Then D2, the formula for D2 is D1 minus the standard deviation times the square root of time. And we have the D1 there. So D1 0.65 minus the standard deviation, I said, is the square root of the variance, 0.15. The variance 0.15, the variance, times the square root of time, 0.5. So D1 therefore will be equal to 0.65 minus 0.15 times 0.5. This is equal to 0.38, or let me call it 37. 0.37. This is D2. D2. All right, D2. Let me take it again to be sure here. I have square root of 0.15. This is 0.387 times the square root of 0.5, 0.707. So this subtract from 0.65. 0.65 minus 0.387 times 0.707 is equal to 0.37. Correct. 0.37. Now we've done D1 and D2. D1 and D2. The next step is to move to the distribution table, the normal distribution table, and put down the values for 0.65, 0.65, 0.65, 0.65, this value here. So we are calculating D1 and D1, normal distribution and D1 candidates, given that this is a one-tailed standard normal distribution and it is on the right-hand side. The tail is on the right-hand side. Therefore, our figure here will be 0.5 plus this is 0. We are getting 0.D137, 0.37. This is 0. I'm reading from the tables, 0.1443. Then ND2, same thing, 0.5 plus 0.37. This is 0.37, 0.37. 0.37 is 0.1443, and 0.65 should be 0.2422. This should be 2422. D1 2422. D1 2422. D1 is 0.65. 0.65. D1 0.65, 2422. Correct. Then D2 0.37, 0.37, 1443. That's correct. So our values will be 0.5 plus 0.2422, 0.722. Then D2 0.5 plus 0.1443 is equal to 0.6443. Now these are the values. We're going to substitute the values into the main formula. The main formula, we have the ND1. Our ND1 is 0.7422. So here we substitute the values in the main formula. This is the underlying asset price we know is 58. Underlying asset price 58. D1, we have it there, times 0.7422 minus the strike price. The strike price is 52 shillings. 52 shillings. We multiply by the D2, okay? D2, we multiply here 0.6443, right? 443 raised to the risk-free rate 0. And candidates, here you need to be very careful because we have the E, which is a base of the natural log, the base of the natural log E raised to 0.06 times T 0.5. 0.5. So we've done the substitution. 58 is the underlying asset price. This is the D1, okay, after reading it and adjusting the normal distribution 0.7422 minus the strike price, also known as the exercise price. We multiply by the D2. This is D2, which we calculated here, D2. Then this is the base of the natural log raised to the, is the base of the natural log raised to negative, this is negative R, the risk-free rate, times time T, 0.5. So we come and insert the answers there. 58 times 0.7422 is 43.05 minus 52. I come here, type 52 times 0.6443. Then I press shift natural log. Then I insert bracket. After this E, make sure you have a bracket. This power, have it in bracket, minus negative. That is minus 0.06 times 0.5 times 0.5, close the bracket. So this gives me 32.5. And therefore, the difference will be the value of this asset, 43.05 minus 32.5. So this, the value here is 10.55. 10.55 shillings. That is the value of the call. The question is, using Black-Scholes option pricing model, estimate the value of the call option. So the value of the call option is 10 shillings and 55 cents. So that is how to calculate the value of a call option. The first thing to do is to put down the formula. There are times the examiner will provide the formula, as was the case here. So this is the formula. There are two things, this minus that. Then within this formula, these inputs must be calculated. So we need to have a workings. These are workings. These were my workings. Working 1, working 2, working 3, working 4. These are the variables that are needed in the calculation of the value of call option. How many marks? 6 marks. 1, 2, 3, 4, 5, 6. 6 marks.